Hello everyone, and welcome back to our 12th and final episode of Math Past Year Papers on ZNotes Live. I'm your host Yukan. I'm here with Devandhira, and today we will do the Math AMA for you guys. Thank you all for your questions we've received, and at the end we have also prepared 4 fun questions from a range of levels for you guys to try and for us to solve. I do hope you guys enjoy. On to you, Devan.
Right. So as Yugan said, this is our AMA session. We'll be answering your questions, and we'll be answering some math questions. So let's get right into it. Let's do it. Let's do it quick. Okay. So first question comes from Alex V. Will there be a sequel? Sequel to the math series? Sequel? Maybe yes, as in like maybe for the updated syllabus. But I'm not sure if I and Yugan will be there to be helping you guys be in the live stream. What do you think, Yugan?
If there is a sequel, I'm not sure that me or Devan together would be in it. But there might be a sequel, maybe. There will be other past year paper sequels, but maybe not math for a while.
Yeah, maybe until the syllabus gets updated, and maybe there should be. Right. So thanks for the question, Alex. Oh, sorry, there's a pop-up. Right, next one. What is the most efficient way to learn, since most people repeatedly solve specific patterns of questions after understanding the concept? The most efficient way to learn math. I see you really have to spend time on it. Find as many resources as you can, like especially YouTube. I like to watch math videos on YouTube, and that's how I learn math from. And for repeatedly solve specific patterns, I guess repeatedly solve specific patterns only understand in one part of the concept. So if you can try to get a question or any resource that will expand your understanding, that would be great. What do you think, Yugan?
If you're learning like basic math, then I think getting a good teacher will help. If you're trying to learn math outside your syllabus or stuff like that, you can use learning resources. Like you can ask some questions in our ZNotes server. Some of us are interested in like math, science, and some other subjects. There's also as Devan said, videos online or resources online that you can use to further your learning, and you can also buy books yourself. About the solving questions, maybe that's not the most efficient way to learn. Something like before doing questions yourself, seeing people do questions and understanding how to do them might be really helpful to benefit your learning. For example, our past year paper series, instead of first learning everything and then doing a past year paper, you can see how past year papers are and how we approach them before trying them out yourself. So that might be a bit easier on yourself, so you don't mess around too much.
Yeah, I agree on that. So is that all?
Yeah, that's all.
All right. So thank you, my Sakurajima. I think that's Melon Red in the Discord. Yeah, Melon Red. Right, next question. How could we best set about memorizing all the formula? I know that repeated practice helps a great deal, but I've had moments where I just can't remember important formula for whatever reason, both in the exam hall and out. Right. Before you memorize the formula, you need to understand the formula first. That way you can memorize it easier. Like example, cosine rule. The cosine rule looks so complicated. A squared is b squared plus c squared minus 2bc cosine of a. Oh my god. But if you understand what's going on behind that, it's basically the relation of the triangles with one of the angles. Is that right, Yugan? That's cosine rule, right? Something like that. While for sine rule, let's say sine rule, it's basically the relation of the side with the opposite angle. So it's like you see that A over sine A is just a comparison of the length and the angle. Right? Yugan? A over sine A is over sine B. It means that the ratio between the length and their opposing sine of the angle is the same. That's what it means. Or in other words,
Okay.
the bigger the angle, the bigger the opposite angle, the longer that side is. Right? That should make
Uh,
sense in the angle. The bigger the angle, the longer the side. So that's what the sine rule is trying to say. And of course, there are other
all right.
more stuff. Anything on the add, Yugan?
Yeah, just adding on to that, memorizing the formula, for me, a lot of formulas stick with me if I understand the derivation of it. And there's loads of videos on derivations of formula. Any kind of formula you can look up. Like as using Devan's example, you can look up the derivation of cosine rule and sine rule, or you can try and do it yourself before trying to look it up. And that way it can kind of stick to you as to how that sort of works. And derivation is not only applicable to formulas, concepts also can work that way. Something like differentiation, when I learned it in school, it was just kind of these are some formulas, just use them. I didn't want to learn that way, so I tried to look up like, okay, how does it work? Why does it work? How do we start? And then, I learned all that. And that way I got a lot more comfortable with the topic myself and also broadened my own learning. So that is something that's really useful for you to do, and that with that you can memorize a lot of formulas. I don't like to say memorize because they just kind of they
Yeah.
just stick. It doesn't feel like memorization.
It just comes to your heart, like when somebody asks you, "Oh, I know it," not because I memorized.
Yeah,
I
it
just know
just
it. You just know
yeah, it
it.
just
Yeah. So that's how I feel when I know formulas. I don't feel like memorizing them. It's more like I feel like I know them already.
mm,
Right.
mm.
So thank you for
Of
that.
course, I don't do
Yeah.
it so much now because I get to use the formula sheet, but so some
Yeah.
of them I still remember.
Yeah. I mean, sure. In AS and A levels, you can use a formula sheet and add math. Right. So thank you for
Mm.
that, It and Alex V. So next one. Which do you think are the three most interesting equations or mathematical techniques that you have come across, and why? Um, Interesting equation or mathematical techniques. First, that I know that's very useful is the Feynman's integration technique, where I'll write it down. So let's say
Mm.
you have the dx of mm, yeah, just integral for some a to b, and then f of x t. Just let's make it general. A function of variables x and t, and this is in dt. This
Mm.
is the same as you can put. So basically, you can put the differentiation inside the integral a to b, but this becomes a partial derivative instead. So for those of you who don't know what a partial derivative is, it's basically differentiating. Let's say this is in partial derivative in x. You see how the d just became curly instead of upright.
Mm.
It's basically any other variables become a constant except for x. So let's say if you want to do partial derivative of, let's say, x squared y, uh, partial derivative with respect to x, this is just the same as 2xy. You just differentiate the x squared, become 2x,
Mm.
and the y just stays. So that's what the partial derivative means. This is one technique in integration. Oh, wait. Oh my god, my iPad's lagging.
All right, that's all.
All right,
Okay.
no. So that's just one. This is one a very cool trick, and mostly integration because I like doing integration. Another one. Let's think of another one. I say when you do integrals using symmetry. Let's say you have an integral from a to b of f of x. Let's say,
Mm.
yeah, f of x. This is just the same as from a to b again, but the inside is a plus b minus x dx. Right there. You can
Ah,
actually prove this
right,
really
right.
quickly. Just when you do a substitution, you put the a plus b minus x. Du is just negative dx.
Mhm.
So let's start from the left integral here. See how we get there. So what? So first, we of course we have to change the boundaries here. When we put b here, this will become a, right? Because a
Mm.
plus b minus b is just a. So that means our upper bound is just a. While the bottom, when you put a here, a plus b minus a. The a gets cancelled and becomes b. But for the inside, of course, we have to make x the subject. And we just have to switch the two here, right? So x is equal to a plus b minus u. So you see there's the symmetry there. So we have the a plus b minus u. And remember, our dx becomes negative du coming from here. So we have a negative du right here. Right. Okay. So by an integral property, I can sacrifice this negative to switch the limits, correct?
Yep,
right.
Correct.
So I can switch it. I have f of a plus b minus u and du. And it doesn't matter what letter you have. You want to use dt, you want to use dw, the omega, whatever. Du is just the same as dx. Right? It's technically the same when I change this into x. And that's how you prove the formula right here. This is the derivation, actually. And it's quite useful when you see some crazy looking integrals. Right. And one more technique is one of the closest thing that I consider the closest to black magic in math. Yeah, I'll show you. It's basically a contour integral. I don't know if you know this. It's a contour integral. This is for complex numbers, for f of z, dz. This is complex number, yeah? It's the same as when you it's the same as 2 pi I times all the sum of the residue of the function in that region, say C here. So in under the region C, how many residues are there? You evaluate them. You take the sum, you multiply it by 2 pi I. You get the answer. You've turned an integral question into a summation. That is crazy. I will not show anything much here because this is, I think, too hard to be explained right now.
Okay.
But yeah, this is called the residue theorem, as far as I remember. Residue. Right. So I guess that's it for mine. What about yours, Yukan?
Nothing really comes to mind except for conjugates. They've just been really useful time to time. Like solving certain integrals, they've been like pretty useful, or like proving them. That's it from me.
Okay. Well, that's fine. Of course, conjugate as in complex conjugate or surds.
Surds or just kind of anything, even trigonometric.
Oh, okay. Conjugate. Okay.
Yeah, conjugates in general.
All right. So thank you for the question, Alex V. Now for the next question, are vectors the same as complex numbers? They basically are. They basically are. Like, let's say if I have a vector 1, 2, and a complex number 1 plus 2i. If I were to draw them, it will look like this, right? 1, 2 dimension looks like this. And for 1 plus 2i, it's also the same. It's so wait, sorry. Yeah, like that. They're basically the same. But I think vectors uses matrices for transformations, while complex numbers uses another complex number, of course. Let's say you have this vector 1 to 2. You want to rotate them by 90 degrees counterclockwise. That means you would use the matrix, the matrix 1, 0, 0, 1, negative 1, 0. Yeah, that is the matrix to rotate 90 degrees counterclockwise. But for complex numbers, I think it's way more simpler. You just have to multiply it by I. That's it. What's the reason? Because remember that, let's say you have a complex number. Let's call it R is equal to REI theta. Remember the polar form of complex number? Yeah. Right? So the thing when you multiply by I is that I is just the same as e to the pi over 2i. Correct? I can just replace that. Let me just put it here. So you're basically multiplying this. So r times 1, this is basically 1, right? 1 is just r. Well, the e to the power of the angle, it gets added up. So you have pi over 2 plus theta I. So you see there that the pi over 2 represents the 90 degrees. And that's what makes the rotation by 90 degrees clockwise right there. So that's the reason behind why multiplying by rotates it. Multiplying by any imaginary part will rotate it, but the real part will scale it. You can say no.
I see.
The magnitude scales it. The argument rotates it.
Mm,
But for vectors, you need to use a matrix for that, matrices. But
mm,
they're almost the same basically. You just prefer what do you want to use. So what do you think again?
mm. I'm not too concerned whether it's the same or not. I mean, to me, like complex numbers can be represented as vectors, but not all vectors are complex numbers. And I just put it, and I don't bother anymore.
Oh, okay.
If you want
And
a short
also,
answer, that's your short answer.
okay. Oh, and also, vectors are technically the same as complex numbers only when they're in 2D, because there's no
Ah,
3D complex number unless you're going to
yeah.
quaternion.
Okay. True.
We
True.
don't talk about it. We don't talk about that. Right. Next question. Are there any short forms for writing mathematical notation that may be useful in exams? Uh, First thing that comes to mind is the discriminant. You write it as a triangle, right? Discriminant as a
Hmm.
triangle. And what else? Writing mathematical
Because and
notation.
therefore,
Sorry. Oh
the
yeah.
because and
Therefore.
therefore symbol.
Therefore, because the implication arrow.
Mm. I
The
often use
implication.
that as a result as arrow, which also works.
Mm. Or when you do induction proofs in further math, you can use the box, the QED box.
Mm.
It means that the proof is done. It's proven.
Yep.
Right. So is that
Uh,
all? Anything else?
I think the question also included when it was typed, like ways to memorize formulas and stuff like that. But
Mm?
I don't have any. Something like yeah, like acronyms to memorize formulas and stuff like that.
Oh, I don't use that too.
Yeah, I don't. We can't help you there. I mean, you can refer to our earlier question where we answered about like memorizing formulas and stuff like that. That might be
All right.
helpful.
All right. I guess that's for the question.
Hmm.
Next one. What got you guys into math or into ZNotes by Pugs? By Pugs himself, the man himself. Right. So for math, yeah, I'll go first. For
Mm.
math, I got into math like ever since I go into grade 7. But that's the start basically. Like
Mm.
because back then when I was in primary level from grade 1 to grade 6, I was just really bad. Trust me, I'm really really bad at math. Grade 7 suddenly I just can't do it. All the teachers that I mean, not all the teachers, everything that the teacher has explained just comes into me instantly. I don't know why. So that it started from there, grade 7, and that's where then grade 9, that's where I started to self study calculus, and that's how I know the calculus stuff, even from undergraduate level.
Mm.
For Z notes, I know Z notes from my friend because I was revising for my chemistry exam. And he told me like, "Oh, you know where to get those notes?" I was like, "Huh? Where?" He's like, "Yeah, you go to ZNotes. Just search ZNotes in Google." It's like, "Huh? ZNotes?" So I searched ZNotes in Google. I searched ZNotes in Google. I was like, "Holy crap! There's a lot of stuff here. this is this is my place to study now." Then after
Mm.
that, like I think last year, 2019, about April, that's when I become a ZNotes contributor. My first ZNotes was Mandarin ZNotes.
Oh,
Yep, I did Mandarin ZNotes first. After that, it's math.
ah,
Yep. What about
I
you?
didn't know that. Into math, like Devan, I was very bad before a certain point. It was year 9 for me. Um, and then it came this assessment that we had to do in school to try and get into the AdMat set because they would segregate students who did math like that. All the AdMat students would have to fast track math in 1 year and then do AdMats fast track in another year. So they wanted to see if students were capable to do that. I think exam grade boundary was 65% to get in, and I got it on the dot. Uh,
Oh,
so I was, yeah, at the
oh,
time I was still pretty bad. And during the holidays, I was like, okay, I'm going to study. Because there was another exam after that to determine if the students in that set were fit for it or not. And some of the students did fail. That set, I got nearly 100%, but I can't remember.
oh.
And after that, I just kept trying to like learn myself, not really self study, because I learned everything in school, but I had to go home and kind of relearn it myself my own way, so it would better stick with me. And that's how I got into math, into ZNotes. Like Devan, I heard it from a friend, but instead of using their notes, he said, hey, you're really good at math, you want to join this Discord server? And I was like, okay. And then like people would ask questions, not only for math, for other subjects, and then I would help answer. And this is my like first actual contribution to ZNotes. I never really did
Oh,
anything before that. Mostly before, it was just helping people on channel. I never really like bothered with much else. But yeah,
oh,
that's math
okay.
and ZNotes for me.
Wait, when did you go into the Discord server?
I went to this about 2 years ago.
2 years ago. Whoa,
Yeah,
when did I
pop up.
join?
I
Oh,
still have the same alias. I'm still KonMari on Discord.
oh my God. When did I join? I
Yeah,
even forgot. I think it was about March. I think March 2019. I think. Yeah, March
mm,
2019. I think that was long
I
ago.
see. Yeah, I
All right.
joined like before IG times to help everyone. That's all.
Oh,
Okay, okay.
okay.
Now we are done with our questions from our AMA session. Now going on to the 4 questions we prepared for you. The first one is,
The first one
um,
is this question right here.
could you
Right.
zoom in?
It looks very scary. Very scary.
Mm,
We have two quadratics. One is the base and one is in the power, equal to 1. But it's okay. We got you right here. So first, before attempting, we have to think what when you play with powers, what makes it equal to 1? So there are, of course, there are, what do you call it? There are situations. There are many situations. Either the power is 0 or the base is 1.
mm,
Correct? But there's one more. If the base is -1 and the power's even, an even number, then it's also 1,
mm-hmm,
right? Because -1 to the power of 2 is just
yep,
1, right?
yep.
-1 times -1. Negatives cancel. Right. So we have many situations, many cases to take on right now. So let's first take on when the power is 0. Right. So for the first one, when x squared minus 13x plus 42 is equal to 0, that's the power right here.
Mm-hmm,
So we can factorize this. We can factorize this into x minus 7 times x minus 6 because minus 7 minus 6 is just minus 13, and minus 7 times minus 6 is just 42. Right.
mm,
That means we got our first two answers, 7 and 6.
mm-hmm,
Agree?
yep.
Right. Next one. When the base itself is 1. So that means we have to equate this to 1, of course. Yeah, our base is equal to 1. So we equate that to 1 right here. Move 1 to the other side. We can factorize our quadratic right here. So we have minus 5 and x minus 5 and x minus 2. That means our answers are x is equal to 5 and x is equal to 2. Agree?
Mm-hmm, yep.
Right. So that's done. We got 4 answers so far. But there's one more that I mentioned before, is that when the base is -1 and the power, and we have to check if the power is really even or not. Because
Mm,
if it is even, then it is 1. If not, then sorry.
mm-hmm,
Sorry. Right. So let's equate that. We equate the base to -1, sorry. Bring the -1 to your other side. That'll be +1. So x squared minus 7x plus 12. Turns out we can also factorize that into x minus 3 and x minus 4. That means our answers are 3 and 4. But of
mm-hmm,
course, this is not the answer. We really have to check it first. So when we check, of course, we put these two answers into the power. Because remember, the power determines if it's 1 or not. It should be
mm-hmm,
even, correct? Right.
yep, yep.
So when we put 3 here, we put 3 in. It was x squared minus 3 in x, right? Plus 42. You just put in 3 in there, and you should get 12. If you put 4, you'll get 6. So both are even. That means both are an answer, right?
Mm-hmm.
Exactly. So that means our answers are just 2, 3, 4, 5, 6. Very many answers.
And 7.
Yep. Oh yeah, 2, 3, 4, 5, 6, 7. Sorry. Right. Anything you wanna add here?
Yeah, this problem was an easy one to start you guys off. The only real thinking, I guess, part is the bottom polynomial equals to -1 and the power has to be even. So that's something you must look out for. I chose this question because a similar question was asked in the ZNotes server a while back, and one of the answers was rejected. I thought this was the same question, but it's not. But now you guys know how to answer like these kinds of questions, where you have a polynomial down here and up here, and it equals to 1 or 0 or something like that.
Yep, exactly. So let's say you somehow got that this is equal to 5. That means your x, this one has to be rejected for real. So you only have 5 answers. Let's say if you happen to meet this question somewhere someday. Right.
All right.
So next question. Right. This one looks also scary, though simple but quite scary actually. We have x plus y plus z is equal to 1. X squared plus y squared plus z squared is equal to 2. X cubed plus y cubed plus z cubed is equal to 3. Find x power 5 plus y power 5 and z power 5. It should be equal to 5, right? Because 1, 2, 3, then 4, and 5.
No,
right?
No. If you guys want, you can pause the live and then continue it to see how we do it. Okay, let's get on with it.
It should be 5, right? Because it's power 5.
Yeah, you.
So it should be 5.
There we go, Devan. It's correct. Okay, carry on.
Right. Of course, we'll have to solve it. We have to solve it by. Well, I use further math method. I don't know if there are any other methods for this, but
you guys can solve it algebraically. I think there was a 50-minute video of it online, a guy solving this question. It is quite a popular question, and yeah, the easiest way to solve it is with roots of polynomials, as Devan will show you.
Right. So we use a further math concept, which is the roots of polynomials. First, because let's call these x plus y and z as the roots. That means it's a cubic polynomial, correct? It's a cubic polynomial. And I don't want to put any coefficient here. It's just gonna make me tired. So it's much better if you don't have a coefficient here. Just put 1 as a coefficient. And of course, we want to find what b, c, and d is. This is the coefficients that we don't know, and we want to find them. Right. What's happening to my iPad? Hello. Right. So don't forget that you put the plus, minus, and plus, minus, because that those are the signs that will determine the coefficients, right? Is that how you say it?
Right. Yeah, I guess.
Okay. So that means we know that there's a polynomial in t. I don't want to use x because there's already an x as a root, so I just use t.
Yeah.
So remember that this polynomial has roots x, y, z. Now first, let's introduce a small notation. We let Sn set S sub n to be equal to x power n plus y power n and plus z power n. So for the first one, this I can just write this as S1. This one is S2, and this is S3, right?
Yep.
Correct.
Yep.
All right. And of course, what we want to find is S5 because x power 5. They're all power 5. Right. Oh my god. Right. So first, we can look for b for the easiest one. Is that because b is just the sum of all the roots, correct? Now remember that the sum, well, not exactly the sum of all roots. It's actually the negative of the sum of the roots. So in this case, our sum of the roots is just 1. So that means negative 1. Negative times 1 is just negative 1. That's our b right here. It's just negative 1.
Yep.
Now for c is a bit trickier. You can find c by using the sum of the squares. So S2 basically. So S2 has a relation of this is basically S1 times minus 2. Sorry, S1 minus 2 times the sum of the two roots multiplied. So this notation right here means alpha times beta Well, not alpha times beta. It's basically xy
Uh,
plus yz plus xc. Basically, it's just a small quick notation because we're all lazy.
yeah.
And 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 this thing right here is actually our c by I don't know by what. How do you say it?
By definition.
Yeah, by definition, you can say. Right, so we can just substitute that as c, and remember that our s2 is just equal to 2. We can solve for c. So c is just negative half. Right, so we got b and c. Of course, we got to look for d. Right, so let's look for d now. So here's a... Wait, sorry. What? It's... All right, so here's a good trick here. If you're doing further maths, you really need to know this trick. It's very cool. So if you have a polynomial like this, you can really replace the, let's say, the t cube or the x cube into s3, the t square into s2, the t into s1. But the constant right here, you have to multiply it by the highest degree, which is 3 right here. I'll tell you the reason why later.
Okay.
So you multiply by 3 here later. Not later, now, I mean. And of course, you can just put the b and c inside already, because we know what b is. B is just negative 1, and our c is just negative half. We want to look for d. But we know what S3... Oh, sorry. But we know what S3, S2, and S1 is from the question given, which is just 3 to 1. Sorry, wait.
We'll be back with you guys shortly. Oh.
Right. Okay. So I'm back. Sorry. I got... What do you call it? Pineapples. Okay. Right. So as I was saying, because we know what S3, S2, and S1 is, we can just plug those in. So we have 3 minus 2. Okay, 3 minus 2 minus half plus 3d. We want to look for d, so we make it a subject. So if we solve it, we'll get negative 1/6. Right. So we got all our b, c, d. That means our polynomial is this, correct? Right, Yukan?
Yep. Correct.
Right. All right. So here. So since... Oh my god, what's it teleporting? Hello? Sorry about that. So since our polynomial is this one, what we've got before, so you can... How do I say it? You can... If you have a polynomial like this, you can really just change the t cube into Sn plus 3. I'll tell you later, it's okay. And the t square into Sn plus 2, and t into Sn plus 1. Well, our constant, there should be the Sn right here. Now, here's the thing. We can look for S5, but before we look for S5, we need to look for S4 first, our S4, because without our S4, we can't look for our S5. So let's do that. So we can first let n is equal to 1. N is equal to 1. That means we have S4 minus S3 minus S2 here, my half S2. And this one will be S1. You can make S4 the subject. We'll solve it. Just put all the values in, put in your side. And you should get S4 is 25/6. Now, since we have S4, we can look for S5. But instead, we'll use n is equal to 2. Because that way, we have the n plus 3. N plus 3, 2 plus 3 is just 5, correct? Right. So that means we can just put this to the other side, solve it, and you should get that S5 is equal to 6. That means our answer for this one is just equal to 6. Not 5. It's 5 plus 1. Right. So what's the reason for that I can do this? Wait, sorry. That I can do this formula right here. I'll show you why. I'll write it small here. So it was x cubed minus x squared minus half x. Oh, sorry, it should be t cubed minus t squared minus. All right. So remember that x, y, and z are roots, correct? Yukan? They're roots. That means if you put x in the t, y in the t, or z in the t, it satisfies the equation that it becomes 0, correct?
Yep.
Step x cubed minus t squared. Sorry, not t squared. X squared minus half. Let me just write them all. is indeed 0, and also for y, I'm sorry, this will take a while. Not over 0, that's illegal. 0, d squared. Right. So you have these three equations, and they satisfy that. So these three values of x, y, z, they satisfy the equation, right? You get. That means if I multiply this whole thing by x power n, and this one is by y power n, this one by z power n, it's also true, right?
Yep.
Both are 0. So multiplying by a number is just itself. It's just 0. So let's expand it. If I were to expand that, what I did before, so I'll get a plus n right here, 2 plus n, 1 plus n, and I will have my x power n right here. I'll move these two also. Plus n, 1 plus n, y n, plus n, 1 plus n, and z n. All right. So you have these, right? Now here's the trick. We will add the equation, the whole thing, the whole equation. These three equations that we got, we'll have to add them. So as you can see for the first one, for the first one, this is basically s of n plus 3, correct? S of s3 n. So I can write that as s3 plus n, or n plus 3, whatever. Next one. The next one is just 2 plus n, correct? But remember, there's minus here. Minus, minus, minus. Correct? We can just factor out the minus, and we get our s of n plus 2. So we have f of 2 plus n. And the same thing for the other one, for the next one. S1 plus n minus 1 over 6, Sn is equal to 0. And that's the reason
1
why...
1 over 3. 1 over 2, because you're adding... Oh, wait. No. Sorry. My bad.
Yeah, so basically, this is where the formula came from. And the reason why that in the last slide... let me do this last slide. In the last slide, there's the tree here. This is basically S0, right? 3 is basically S0. X power 0 plus y power 0 plus 0 power 0. 1 plus 1 plus 1 plus 1. 3. Right?
Okay.
For this one, I was talking about this one. This tree right here. From D to 3D. This is basically S0, because S0 is just x power 0 plus y power 0 plus 0 power 0. This is just 1 plus 1 plus 1, which is just 3, of course. Okay. That's the reason why. Right. And that's our answer. It's just 6. Not 5, okay? It may look deceiving, but it's not 5. It's 6.
Okay.
Okay. Yeah?
We have a question from our chat. What is the best way to revise for AdMaths IGCSE apart from doing a lot of practice questions? We've addressed something about learning math earlier, so if you want to check that out first, please do so. You can just run back to when we answered the questions. For revising, if you've already understood all the concepts and everything, probably the best way is to do practice questions. You could also try to further your own learning to the point where the stuff that you learn now becomes trivial, but that might take a bit of time.
Yeah. For AdMath, best way to revise really is just to understand the concepts, really. Because I don't know, Cambridge math is just like that, the math is just like that. Nothing to be very careful about. Maybe there are a few trick questions, but it shouldn't be that hard, really. Yeah, I guess that's it. So
yeah, we've addressed something about learning. We've addressed something about learning earlier. Please check that out. Yeah, and thank you for this answer. That's the right answer.
All right, so let's move on. It's a geometry question. So before, let me just erase this all. If you want to solve this by your own, right here.
It's lagging.
Okay. There you go.
Okay, there we go.
Solve it by your own. Check it out. You can see the answer is right here. You see the answer. But I'll show you how to do it.
All right, yeah. So if you guys want to pause and give this a go, you guys can do that. You might get a decimal answer 0.3 something something, but that would be the right answer. Yeah. You guys can easily do this with coordinate geometry, or you guys can try to do it geometrically, but that involves a bit of like drawing
It's
on the
not
diagram. Yeah, it's not an easier method because it's not that hard to. It's kind of hard to see, but here you go. Devan will show you.
All right, so I shouldn't be showing. It should be you, but whatever. Sure. Right. So
If you want me to explain.
right. So before we start it, let's make some few triangles here. So I'd like to show you about this diagonal of this a square. We have a square of length 1 and the circle of radius 1/4 or 0.25. So we have a diagonal here, this long diagonal. Yeah.
Mm.
And of course, we want to find the shaded area of this. This is what we're trying to look for, the shaded
Right.
area.
I forgot to mention that the question is to find the shaded area.
Oh, yeah. Yeah, shaded area of this black triangle right here. Shaded triangle. Okay. Now,
Pop up,
here's
David.
oh, sorry. Now let's refer to two triangles. First, we're going to refer to this one, this triangle right here. And the other one is the right angle triangle. This right angle right here. Okay. So we got those two right here. So this is the smaller one, and this is the bigger one. This is just to refer the shaded triangle, so that it's more understandable. But whatever. First, we're gonna look for what the length of H is. So as you can see, I've highlighted where H is. This is how I label H. You can label it whatever you want. You label it X, Y, Z, T, A, B, C, whatever. I just call it H. And how to find H? So, oh my god. So if you want to find H, of course, you can get the whole diagonal first. You can use Pythagoras, and you should get that this whole diagonal is just root 2. Agree? You can?
Mm-hmm.
Root 2. Then we have to subtract off this small part right here. Correct?
Mm.
And of course, you can just, because our height is just 0.25, and our length is just 0.25, and this is a right angle triangle, you can just use the Pythagoras again, and you should get that is 1/4 root 2.
Mm.
And because you're going to find H, you would have to do root 2 minus 1/4 root 2 right here. Or you can just simplify into 3/4 root 2, whatever.
Yep.
You can also do that. Right. Now notice that I put alpha here. They're the same angle because this is the angle in the figure. And we want to look for sine alpha. So to do that, we know that sine is the opposite over the hypotenuse. And in this triangle, this is the opposite and this is the hypotenuse, right? H is the hypotenuse in this case.
Yep.
That means it's just 0.25 over H. And this is how we write it. So you see the 0.25 over our H, of course, our H. You can simplify this using your calculator. It's just root 2 over 6. Agree?
Mm-hmm. Yep.
So
yep.
far, right. Now another angle that I want you to know is beta. Right here. This is beta. Okay? So beta's right there. In the triangle, the beta's right here. Right. So how to find beta? So of course, the angle add up, all the angles in the triangle, when you add them up, is 180. That means if you want to find beta, it's just 180 minus 45 minus alpha, right?
Mm-hmm.
So if you want to find, so we have our 180 minus 45 and minus our alpha. So how do I get this? It's basically from this equation, and just take the sine inverse of both sides. That means our alpha is just sine inverse of root 2 over 6, correct?
Mm-hmm.
Right. You can simplify more, of course. 180 minus 45 is just 135. And you should get this as your beta. Right. So next one. So we can use the sine rule here. Now, let me tell you what x is. So x is this length right here. This length. In the figure, it's this length. The hypotenuse of the shaded triangle, basically. That's our x. And we want to find
Okay.
what's the value of that, of course. And I'll tell you why later. There's a reason why we want to look for that. So we can use the sine rule. So remember that. Let's see. I hate my life. All right. So remember the sine rule is just the length over the opposite angle, correct? So if we have x right, the opposite angle is just 45. So it's x over sine 45. Same thing for that. But we would use root 2 instead. Root 2 is the hypotenuse here. And we know what beta is. We wouldn't use alpha because I don't know what the length of this is, correct?
Mm-hmm.
I don't know what this length is.
All right.
Yeah. And so that's why I decided to use beta and this length. So we use the sine rule on that. And with that, we can just solve for x, and you should get that x is the cosecant of 135 degrees minus sine inverse of root 26. This is basically alpha. I did a bit differently from you, Yukan. Just did a small difference.
All right, that's fine.
Yeah. So now, because we know what x is, and we know what the length of this is just 1, because it's just the side of the square. That means we can use the area for a triangle using the angle. So it's this one, half AB times sine C. Right. So we have our half, of course. Our A and B are basically the adjacent length between the angle. So in this case, we're going to use this angle. And these are the adjacent length, 1 and x. So first I put x inside here. This is our x. But for the angle inside, so remember that the angle made by a diagonal in a square is 45 degrees. This whole thing is 45 degrees. Agree?
Yep.
Right. So that if we have alpha here, that means the other one is 45 minus alpha. So we can just put that as our angle. So we have our sine of 45 minus alpha right here. You can just put this in your calculator, and you should get this as your answer. 9 minus root 17 over 16. Right? And that's how you solve it. Anything to add here?
Yeah, for those of you who can't figure out why we do it geometrically, or if this is something like, oh, that's how you do it, but how would I ever figure it out? If you could zoom in, Devan. So if you erase everything, you have to try and just kind of draw stuff that might be a bit obvious, but something that could possibly be useful. Just try and draw obvious things. So in this case, right, we can see that the circle is tangent to the sides of the square. And we know that because R would be the same, obviously, throughout the circle, if you draw a straight line down R, you would get another square, a square with the length 0.25 and 0.25. Because it's a square inscribed in a square at the corner, the diagonal of the square should pass through the center of the circle or the corner of the smaller square as Devan has drawn. Also, this shaded region, its side length is perpendicular to the circle, or tangent to the circle, I should say. So if we draw another radius to it, we can draw a right angle, Devan.
Oh, sorry, how?
Draw a right angle at the tangent to the circle.
Tangent is like this?
No, to the tangent to the circle of the shaded region.
Oh, this one.
You see how yeah, that one. So that is a right angle. And with this information, we can already start to see the sort of things that we need. So we know that the radius length, just label all the radius that you drew as 0.25.
0.25.
Yeah, you can kind of start to see everything coming together. Not that radius, Devan.
Wait,
the one in the square.
But there's already a radius here.
No. Yeah, that's fine.
Okay.
So we can start to see everything kind of piecing together. And now you know that the diagonal is just the diagonal of a square. It's just the root of 2. And then the diagonal of the smaller square is the root of it is the 1 over 4 times root of 2, or 0.25 times root of 2. And then with that, you have the diagonal of the right angle triangle that you just made. And you know that if you cut the square in half, the area would be 0.5. And that minus the area of the triangle inside, you would get your answer. That's how I did it. Devan instead found the side length. Using that triangle, he found the side length of this other triangle, the shaded region 1, and then found the answer. So
Yep.
that's kind of the explanation of to how you would kind of figure it out. With any kind of geometry problem, you do have to draw anything that's obvious and then use basic shapes to try and figure out what the other basic shapes are in the geometry problem, and then you would be able to solve them. So I picked this problem because I thought it was a very instructive geometry problem that would take really long with coordinate geometry, but with a bit of simple basic geometry and trigonometry, we can solve it.
Exactly.
Devan molding right now because he first did it with coordinate.
Yeah, I did this with coordinate geometry. I mean, I got the answer, but oh my god, I had to solve.
I tried it with coordinate afterwards, and I got an answer that was very, very close, but not
Wait.
the exact value.
Oh,
So
I got the exact value. I got the exact
no,
value.
no, I just might have like gotten a simple mistake somewhere. Pop up, Devan.
Oh,
Yeah, and I
oh,
didn't bother to do it. I did the geometry way first, and that was fine. So
oh my god.
all right, moving on.
All right, let's move on. Right, last question. It looks very, very hard. This actually came from a book called Almost Impossible Integrals, Sums, and Series.
Oh, you have that book?
Yeah, I have that book.
I've heard of it, but I've never like actually seen it to buy it. Or I really want that.
Yeah, this is one of the integrals there, and they
I
even
see, I
challenge
see.
us to use high school knowledge to solve this question. Right.
Mm.
Of course, we can do it. No problem. But of course, before that, we want to know what Hn is. What's this Hn? What the hell is this? So of course, I'll tell you what it is. So Hn, I have a voice crack. So it's defined as the harmonic series, actually. Harmonic series, the finite. So it's 1 over 1 plus 1 over 2 plus 1 over 3, 1 over 4, until 1 over n right here. Or in other words, using summation notation, it's basically the sum of from 1 to n of 1 over k.
Mm.
Okay. Right. That's what Hn means. Sorry. Okay. So let's start.
Hang
So
on.
first-
Before that, Devan, we have a
Yeah.
question from YouTube. Please explain binomial series. This series is not for that. You're asking the wrong people. If you wanna explain a concept, there's a lot of videos online, and you can go ask your teacher if you're not too familiar with the topic. If you have any specific questions, please send them in the ZNotes Discord.
Yeah, can just come to our ZNotes Discord. And I'm pretty sure people will help you.
Mm.
Okay. So sorry about that, sir. Let's get started. All right. So I just rewrote the integral. Nothing changed. Now, so we first know that the natural log of 1 minus x is the same as the negative of the sum of xk over k from 1 to infinity.
Mm.
There's a reason for this. Let me try to explain it here. Just make a new page, whatever. So here's the reason. You remember about the... Do you remember this? You good? Remember this?
Yeah.
This is basically 1 plus x squared plus x cubed until infinity, correct?
Mm.
In other words, I can just write this as a sum from 0 to infinity of x power k, correct?
Mm-hmm.
Now, how do I make it to learn?
You can integrate it.
Yeah, you integrate it. You integrate dx. You integrate both sides, basically. So if we, in the left-hand side, we have negative 1 minus ln of 1 minus x is equal to, of course, when you integrate a sum, you can just interchange it. At this case, you can interchange it. So you have the sum of k from 0 to infinity. Now the integral of x power k is just x power k plus 1 over k plus 1, correct?
Mm-hmm.
Right. So from here, but the k plus 1 is kind of bothering. So in order to change it, we can just reduce it by 1, but I have to increase the k from 0 into 1. So instead of starting from 0, we'll start from 1, but our power is just k, and the denominator is just k. Then we
Yep.
can just multiply negative both sides, and that's how you get it.
Just to add,
Yeah.
you do also -1 from infinity. I mean, add 1 to infinity, but then that just stays. If you're doing like a definite series, not to infinity, then that top part will change as well.
Yep, of course. That's true. Because infinity minus 1 is just infinity, or plus 1 even.
Yeah.
Right. So that's how we get it. And so let's move on. Right. So instead of writing the ln of 1 minus x, we write it as this way, how we found before. So remember, we can just pull the summation out right now, because it's interchangeable at this case. And that means I also can put the k in the denominator outside. And that's how I have it right here. And the powers of the x has to add, right? It's a multiplication, so you add the power.
Yep.
So it's n plus k minus 1. And the minus 1 comes from here. Right. So that means we have right here. We have this right here, and we can just integrate normally. So when you integrate x power n plus k minus 1, that's just x power n plus k over n plus k, correct? Remember, we have to evaluate it from 0 to 1. Right. So we put 0 is actually just nothing. But when you put 1, you'll get 1 over n plus k. Agree? Right.
Yep.
So what's next? I copied the same thing. My God. All right. So I just copied the same thing. Now here's the thing. I would do partial fraction in here, so I would get this. This is how I get here into here. This is by partial fraction. If you notice, you can do it by yourself if you want. But if you notice, if you combine this, you would get this back. Right. So agree here so far, Yukan?
Oh yeah. Okay.
So from here, we can. Of course, it's hard to evaluate this, so we can expand it and see what happens. So when we expand it, you see. Remember, it's the k that we're playing in, not the n. We're playing with k. So we put k equal to 1, then 2, then 3, then 4. So you see here, we have 1 over 1 minus 1 over n plus 1. The k is right here, so it becomes 1. Then 1 over 2 minus 1 over n plus 2. 1 over 3 minus 1 over n plus 3. Now here's the thing. We keep adding. All right, so we keep adding until the k becomes n. Hello, Yugan? Hello, Yugan? Am I lagging? Hello? Am I lagging?
Hello, Devan.
Hello? Am I lagging? Am I lagging? Hello? Oh, I think he is lagging.
Hello, Devan.
Yes, hello. How are you?
Oh, okay. I'm back.
Oh, okay.
My internet cut for a moment.
Yeah, it's okay. So as I was saying, so we have to add from k is equal to 1 to infinity. So what we have here is from 1 to 3, and then just time skip. We let until k is equal to n. This is where the magic starts. Until k n, then n plus 1, n plus 2. So here we have our n plus 1, and n plus 2. Now here's the thing. You see that the n plus 1 right here will also cancel right there. Can you see that? Same thing for n plus 2. And here's the thing. These guys will also cancel from the future terms, right? Because you will for sure reach k is equal to 2n, because we're going from to infinity, correct? That means we will reach 2n, and this will also get cancelled. So as you can see that everything here gets cancelled except for this part. Right. So let me rewrite that. So everything except for this part gets cancelled. So when we rewrite that, and here you go. This is the harmonic series, our Hn, right? That means, so we have our negative 1 over n times our harmonic series, and that's our answer. And that's how you prove it.
Really nice.
Very simple. See, only high school knowledge. Nothing crazy. No crazy techniques. Oh, the only crazy thing is just this part right here. But it's even easy to prove. Right. So yeah, that's it.
All right, that's really cool.
Here, Yukan.
No, I think you explained it really, really well.
Okay.
Yeah, I just didn't know what the notation Hn meant until you told. But other than that, yeah, it's pretty. It's a really neat integral.
Yep. It's very nice.
So,
I like these kinds of integrals.
so that's the end of our stream, and that's it for today, and the end of this series. Oh,
Do
what?
you have any more? Do you have any more questions?
No, let me check
the comment?
Oh wait, yeah, there's this guy that says explain 1 equals to 2.
Oh, that's very simple.
1 is not.
Very simple. Here. I show you. Yeah, I show you. We have
Oh.
okay. So 0 times 1 is the same as 0 times 2, right?
Pop up,
We
Devan.
divide
Pop up.
by 0. See? All right. So basically, you agree that 0 times 1 is equal to 0 times 2. Both are 0.
Correct.
You divide both by 0, you see that they cancel. So 1 is equal to 2. That means the score that you get in your test, let's say you get 100, is the same as 0 or 1 or 3 or 5.
True.
That means
Any
your score
number equals to any other. Numbers are arbitrary and abstract. They have no meaning. Anyways, obviously that's crap. Don't divide by 0 or multiply by 0. You'll get stuff like this.
All right.
Okay, yeah, we have no other questions, and we have no questions in our slides. So that's it for today and the end of this series. I hope all of you enjoyed the session and learned something valuable. Thank you, Devan, for taking your time to do this session and this series. Please follow our social media shown on the next screen. Give me a sec. All right. And if you aren't already in our ZNotes Discord, please join that too. We're most active there. I'm KonMari and Devan is the Pirot. You guys can ask us questions or the server any questions. And enjoy the rest of your day and have a good night. Devan?
Thank you for this series, guys. Bye-bye. See you next time.